Hello, and welcome to the webinar titled Automated Trading System Development with MATLAB. My name is Stuart Cazzola, and I'm the Computational Finance Product Manager here at the MathWorks. The agenda for our webinar today is shown here on this slide. So we're going to start out with talking about some of the challenges that you can face when creating an automated trading system. Then we'll dive into an automated trading workflow and discuss how MathWorks tools can be used to address many of the different capabilities in that area. And then we'll actually get our hands dirty and jump into MATLAB and show a demonstration of how you can design an event-based trading system within MATLAB. And then we'll also look at another set of tools, Simulink and Stateflow tools, that can be used for high-frequency trading towards the end of the webinar. And then we'll wrap up with additional resources and where you can go for more information, as well as a Q&A session at the end of this webinar. So first we're going to start out and kind of set the stage for challenges that are often faced in developing an automated trading system in a variety of different tools that exist out there in the market today. And then through the course of this presentation, we hope to address many of them through product demonstrations, as well as some of the slideware that'll kind of address many of these capabilities or these challenges that are shown here on this slide. So the first one that is often brought up is that many different trading systems are black boxes. They're hard to customize. They may have you locked into a variety of different data feeds. So you're really limited in what you can do within a certain trading system. Another thing that we often hear from our clients is that there's a very long development time. Sometimes the black boxes do have an API, but the API is often difficult to program or requires a different skill set from the trader set. So now you need a trader as well as a software developer to implement new trading logic or new ideas. And as mentioned earlier too with the black box capabilities, many different strategies today are working across multiple asset classes. They require many different data feeds, such as new sentiment data, as well as live market data, as well as maybe historical accounting data or fundamental data. And then of course they want to execute their trading strategies across a variety of different trading venues, from foreign exchange to equities to fixed income markets as examples. And then of course there's a need for complex numerically intensive computations, and if you follow any of the news today about machine learning and artificial intelligence being brought into the trading community, you'll know that more and more statistical or machine learning algorithms are kind of being implemented and used to try and come up with an edge within the markets. So how do you integrate these into computational systems that maybe were not designed from an algorithmic development standpoint? And then of course the time cost in developing and deploying these systems to your end users, or if it's yourself, how fast can you get your ideas to market is kind of critical. It's often been told to me by customers that if it takes you 6 weeks to develop and implement a trading strategy, the trading strategy is probably already irrelevant in the markets. We really need to turn that around to weeks, if possibly days. So with that, let's jump into kind of an explanation of an automated trading system development workflow, and then we'll map that to kind of the different products that the MathWorks offers in this space, and dive specifically into a demonstration. So the first thing is when you develop a trading strategy or you want to work on developing an automated trading system, you need to take in consideration the data sources from files, maybe they're from databases that you have, historical data, maybe they're from other data that's provided by other vendors, as well as live market data feeds. These are all used in kind of implementing the trading logic that's either used to backtest your strategies, develop new ones, or to kind of seed the trading strategies with historical data so that then they can move forward with existing live data. So the data is fed into this research and quantify stage, which is basically where you come up with new trading ideas. So what MATLAB allows you to do is a variety of different things, from data analysis and visualization to financial modeling, to as well as developing complete applications that you can run directly from within MATLAB to kind of show how a trading pad might work. So you can go from creating new machine learning algorithms to developing a novel financial instrument to actually creating a dashboard that maybe a portfolio manager would be using, all within MATLAB. And then of course, how do you share this and communicate the results of your idea or implement this into an automated trading system, which is really kind of the focus of this webinar. So MATLAB allows you to do a variety of different things, such as automated report generation. You can integrate MATLAB into deployed applications, and later on in this webinar we'll talk about how you could even consider implementing MATLAB algorithms and a co-located exchange, for example, as well as implementing MATLAB to be called from databases or as its own standalone automated trading system. And of course, the value and benefit of doing this within the MATLAB environment is that you can automate the entire process from the data collection to the sharing and reporting to automated trading. And that's the value that MATLAB brings to the table. So when we look at that from the perspective, MATLAB kind of spans the capabilities of all of these areas. And then there are different add-on tools that we call toolboxes that extend MATLAB, our platform product, with a variety of different capabilities for each of these different application areas. So first we'll focus on the access side. So there are different tools for connecting to live databases, including historical data feeds as well. And then of course there's the ability to link directly to a spreadsheet link, because many many traders like to use spreadsheet as a simple calculation pad, and maybe you'd want to integrate those calculations directly within how you'd be executing an algorithm, or use it as kind of a order entry sheet, if you will. And then, of course, there's the kind of the mathematics that you'd like to apply within your strategy development. So there's a variety of different tools, from statistics to neural networks to optimization to machine learning to some finance-specific functionality, some portfolio optimization, to the ability to calculate yield curves and financial instruments, as well as do financial forecasting and econometrics. So these are all different capabilities that are included within the MathWorks product lineup that you can then select and choose from to help you implement particular trading strategies. So for example, one popular trading strategy today is to use co-integration for pairs trading. Now, pairs co-integration functionality is within the time series functionality of the econometrics toolbox. So many of our users are using co-integration to develop pairs trading strategies, or even multiple pairs trading strategies, because co-integration can be applied across more than just two assets. It can be applied across many assets at the same time. And then, of course, when you need to get your idea and algorithm out of MATLAB, if you're not completely developing the trading system to be run from within live MATLAB itself, or want to lock up a license of MATLAB for automated trading, you can then deploy this through a variety of different mechanisms. What we have shown here is a variety of different deployment capabilities, beginning with a compiler that allows you to build standalone executions and a variety of different targets. In a minute, I'll come back to those because that product lineup has changed recently, and I'll tell you what's different with them. And then, of course, there's a production server, which I'll talk about towards the end of this presentation, which allows you to host up MATLAB calculations as a calculation library or a calculation server. So you can actually run a variety of different calculations all from the MATLAB production server. Its capability is around 10,000 transactions per second for simple strategies, and you can scale it based upon the hardware you have. We'll talk a little bit more about that later. And to continue on with the scaling theme that I just mentioned, there are also two other options: parallel computing for using all the cores that you have on your current existing machine, as well as the ability to dispatch calculations out to a computational grid, cluster, or cloud using the MATLAB distributed computing server. And more recently, we've added another toolbox to the lineup. It's categorized under Access, but it's really about market access, accessing live trading data from a variety of trading venues, as well as sending order information out to a variety of different trading systems. So the ones that are currently supported in the trading toolbox are CQG, Bloomberg EMSX, Trading Technologies Xtrader, and Interactive Brokers, as well as a generic fix engine from FixFlyer that you can use to communicate with any fix-compliant trading system or financial system that's out there today. Now, I wanted to mention that the product lineup has changed here recently, actually this year. So we've actually changed how the deployment capabilities work. So we have the MATLAB compiler, which allows you to create any kind of standalone application, including applications for Excel. So you can create Excel add-ins, or you can create a standalone application from MATLAB. That's what the MATLAB compiler now enables you to do. We repackaged many of the other products into what we call the MATLAB Compiler Software Development Kit, or SDK. Now this allows you to deploy MATLAB to a variety of different platforms, including production server, including Java, .NET, and Python currently added, as well as C, C++, and other libraries, as a DLL or shared library as well. It's all through the MATLAB Compiler SDK. So what I'd like to do now is to actually kind of set the stage for the demonstration that we're going to build within MATLAB. I assume that you have some familiarity with MATLAB, but even if you're new to MATLAB, we'll give you a high-level view. But we're going to dive quickly into some more advanced concepts. So if you do feel like you get lost, I recommend that you check out some of our earlier trading webinars. They kind of go from a new user's perspective to developing a strategy. We're going to jump in and kind of take off from there and move to more, how do you do event-based trading within MATLAB? So let's begin with discussing how we're going to build a trading strategy or a automated trading system all within the MATLAB environment, where each of these components can then be replaced with something different. So what we're first going to do is we're going to jump in and talk about how do you create a streaming data component. This is going to actually be a data feed server, or what we're going to really use it as a data feed replay service. So we can replay historical data to test our algorithms before we actually turn it on and implement it as a real-time automated trading system. Now, of course, the streaming data is going to provide tick level data or level 1 quote data in this example that we'll be showing to a variety of different trading strategies or trading systems that might be listening to that. So we're going to basically model two different trading systems in MATLAB. One is going to be a market maker whose goal is not to necessarily generate profits, but to provide liquidity and make revenue from the rebates he's going to be getting from the exchange. And then we're going to look at a simple momentum trader that we've used in prior webinars just to keep forward with the concept of how you can develop a trading strategy in MATLAB. This one will be for profit, and we'll look at backtesting it as well as walk forward testing it, and then seeing how it performs in a real-time streaming environment. And then of course you need to be able to send trading orders out to a trading venue. So we'll actually create another object that's actually going to be a trading execution system or order management system. It'll accept the orders, keep logs of all the trading activity, as well as the quotes that comes in. Now this is going to be a simulation environment in MATLAB, but keep in mind that the streaming data system can easily be plugged in from a variety of different data sources from the data feed toolbox, such as Bloomberg, Thomson Reuters, FactSet, Interactive Brokers, for example. And then of course you can replace the trading venue that we're going to be using with a very similar component, such as Interactive Brokers or a fixed compliant trading system. So of course what we're going to do is we're going to begin with defining our historical data set, feeding the historical data set to our streaming data object so that we can backtest and calibrate and see how the real-time performance of our system goes. Those strategies will then be implemented and, be listening to the streaming data. So everything's going to be driven off the data source, or basically anytime a new quote arrives, the whole system downstream will be responding to that. So this is going to be an event-based system. And then of course, once the trading is done, you can actually pull out, or you can pull out at any time during the trading records of how the orders have been placed or what was the quotes that are currently in the trading system. So with that, let's go ahead and jump into MATLAB. I'll give you a real quick brief overview and then we'll dive right into building the system. And then we'll come back, talk a little bit more about the MATLAB production server, and then jump back into tools for high frequency trading. Okay, so we'll transition over to MATLAB. So for those of you that might be new to MATLAB on this broadcast today, let me give you a real quick introduction, then we're going to dive right in with some examples and get going. So basically what you're looking at is the MATLAB development environment, or the MATLAB GUI. And it consists of a variety of different components, such as the command window, where I can enter commands, the current folder, which is where my current working directory is with all my data and other additional files I might be needing that are accessible through MATLAB on the path. You can see the current active path is shown here. The folders that are highlighted here are actually accessible, so anything that's under here, such as the data, can be pulled into MATLAB. It knows it's there. The folder is slightly grayed. It's not on the path, so anything within these folders, MATLAB does not know how to access because it's not added to the path. You can add them to the path by simply going Add Selected Folders, and anything within those directories are now available for me to call as a command from MATLAB. So in the workspace, this is going to provide any workspace variables that are available to me to work with in MATLAB. So as I walk through the introduction, we'll kind of see how many of these different components interact with each other. Then there's a variety of tool strips tabs up here that do a variety of different things, such as working with files, data, adding different plots, creating or working with different applications, and then any shortcuts that I may have defined, such as cleanup, which basically just removes any variables and resets my workspace. So what we're going to do is we're going to start basically with a very simple example. I'm going to kind of bring everything up with this example lead lag trader. I'm not going to walk through the entire script, but I'm going to show you quickly how you can develop and backtest a trading strategy with a variety of tools. Then we're going to move into demo 1, which is actually going to start developing the automated trading system all within MATLAB. So let's go ahead and double click this to go ahead and open up the file. Move it over here so I can get a better look at it. And what we're going to basically do is create a lead lag trader, which is basically working on two moving average indicators that cross over, or two moving average indicators that work on data. So the first thing we're going to do is we're going to load in some data and backtest the strategy. So what I have here is basically the function to load in the Microsoft data contained in the data folder. You can see Microsoft data here. I can also select it and then also look and see what's contained within it. So I have a Microsoft bid and ask and an exponentially weighted moving average of the bid and the ask as well. And it's about 50,000 variables in size. So we'll load that in. So for example, the midpoint of the bid and the ask. So let's go ahead and evaluate the selection. Now I have Microsoft price. So if we're going to trade on the midpoint using a lead lag moving average indicator, this is the example that you'd see here. So basically what we have here is a leading indicator that's at a period of 12 and a lagging indicator that's slow that has a period of 26. So if we zoom in, you can get a better view of how this is looking at the bid and the ask, or the midpoint price, and how it's trending and following. Then you can see as they cross over, we're generating a trading signal. And then we're also keeping track of the cumulative returns within this plot. And you can see how frequently it trades given these leading and lagging indicators and the return, and then the cumulative return series that you'd see here. So this is an example of a real quick back test. So with that, what I want to do is define what are the best parameters I can use. So we're going to do a parameter optimization or parameter sweep and figure out what's the best way to do that. But what we're going to do is we're going to use all of this data. We're going to use about half this data to come up with a trading strategy and then test it on the other half to see how tests works on out-of-sample performance. And that's essentially what the scripts here are doing. So a script is basically an encapsulation of MATLAB commands with comments. And these comments can actually be used to help document your work and create automated reports. And we'll show that in a minute of this. But what I want to first do is run through this example. So what we're going to do is we're going to backtest the strategy. So loading in the Microsoft data. We're going to change the parameters 1 to 80 and then 80 to 200 in steps of 5. So this is going to be my N and M parameter, or my fast and slow moving parameter for the lead lags. Define them as a range variable. The annual scaling is so that we can get a Sharpe ratio, because this is going to be daily data for quotes. We're going to assume that the quote resolution is around a second. But at the end of the day, we want to annualize the Sharpe ratio that's calculated to what would be an annual, so we can get a feel for how this investment performance works versus others that might be on an annual performance. We're going to run it on the midpoint of the bid and the ask. We're going to assume a cost of about 0 for the moment. You can add this later, and it does change the performance. Now I mentioned I wanted to break it into 2 halves. The first half is going to be my test set. So we're breaking an index from 1 to the midpoint of the 50,000 series that's shown here. And then we're going to do a validation set. So this is our validation set. Now to run a parameter sweep, what I want to do is I want to basically define the lead lag function here as a function that can be run with a variety of different parameters. And that's what this lead lag fun here does. So if I go ahead and open that, what you can do is you see this goes through and it will actually handle the variety of different conditions, NANDs, calculate the scaling parameter, and then actually run it. And it just makes sure that N and M can't be greater than each other because it wants to run over an entire sweep. So M always has to be greater than N. So it's going to basically eliminate those conditions. And then we're going to define this as a function handle. So what this @ symbol means is I'm going to take this function, pass the function as an input to another function that's then going to run on it. Now this is a standard concept in MATLAB that's often used in our partial differential equations or our differential equation solvers, ODE solvers, as well as our optimization solvers. So these are functions that operate on top of a function. So I've redefined lead lag using this @ symbol as a function that I can then pass through it, give it the range, and the parameter sweep is just going to run through all those different combinations. And in addition, parameter sweep is actually going to use parallel computing in the background. So if I go ahead and open this up, what you're going to see is I have some loops that's going to loop through things. Or I'm sorry, it's not within the parameter sweep, but it's actually within the lead lag function. So if I go ahead and open it back up, what you're going to see is I have a parallel for function. So it's going to run every one of those parameter sweeps in parallel using a different core. And this will take about 30 seconds on my dual-core laptop, so it's not a very intensive computation, but many others might require more resources. So when I run this, you're going to see that parallel computing is going to start using two workers, go through the parameter sweep, and then it's going to report the results. And we're going to just report the best performance from a Sharpe ratio perspective. And then we're going to go ahead and put that back into the lead lag function to get a plot, because the lead lag function without an output gives us the lead lag plot that I showed earlier. So let me go ahead and run this. You can see it's opening up the parallel worker pool. So it's also going to end up showing that I'm going to be connected to my local, which is my laptop. You can connect to an extensive distributed computing system. And then you can see it's connected to 2 workers because I have a dual-core laptop by default. So now it's actually going through and running on all the workers on my laptop. And then it took about 24 seconds to run the parameter sweep for all those combinations from 1 to 200 basically. Squared because you're running across another set of 200. So it ran through and it said for 50% of the data set, it said to use 13 and 17, but if we run it across the entire data set, this is what we get. Or no, I'm sorry. So this is the first half of the data set. This is the test data set. It says we get Sharpe ratio 1.2 and a 4.57% return. It's not too bad. Now let's actually test it on that other set to see how well it works. This section of code here will do that. And what you see is that it actually took a loss and a bad Sharpe ratio. So on the second set of data, it didn't do quite as well. If you remember, this was the downward trend, a little less volatility than earlier in the day. So 13 and 7 calibrated to the characteristics of the first half of the data set well, but it didn't work well out of performance. And that's not really a good strategy. So what we want to do is go through a walk-forward testing strategy and look at how this will actually work. Identify the lead lag combinations that will provide us the best performance regardless of what the market conditions currently are over the day. So we're going to do the same thing. So what we're going to do now is we're going to run the lead lag function over the Microsoft price on a window. So we're going to use a moving window. So if you remember, we looked at, for example, so we're going to look at, this is the whole set of trading days. So what we're going to do is we're going to take a moving window approach. So we're going to define the window to be about 5,000 samples. So this is a 50,000 general, so it'll be about, the first window will be about here. We'll test it. We'll increment it by about 1,000. So we'll test it to the first 5,000, move it over, so it'll go up to 6,000, and continue to see what kind of parameters we get out of this. And then we'll report the results. And is a plot that we can look at and identify what the best parameters for the lead and the lag indicators are. So if we go ahead and run this, it's going to take a little bit of time to run because it's got to run through a variety of different combinations. It's actually going to take around 2 minutes to run on my laptop for this. But what you can see is that we're reporting to the command window the Sharpe ratio and what the values for N and M are, 5 and 63, 1 and 8 in this case. You can see that we're getting some good Sharpe ratios for different ratios. The 13 and value that was shown earlier don't appear to necessarily be the best over many cases. So we're going to sweep over the entire data set, and then we're going to kind of look at which ones were the best one. So while that's running, what I'm going to do is actually go and talk about how you can create a published report of this. So one of the things you notice is that I have different segments that are highlighted by double percents and then other comments here in green with the percent symbols. Now these can actually be used in what we'll call a publication mode. So you can publish your scripts into an actual report. And the way to do that is go to the publish command. You can insert a variety of different things such as images, latex equations, code. And then you can also publish to a variety of different formats. So for example, you can see you can support HTML, XML, LaTeX, Doc, PowerPoints, and PDFs. So we're just going to go ahead and use the default one. This is running currently, but what I would do is like push publish. It'll go through, run all the code that's in here, capture everything, and include it in a document, which is now in the HTML folder. So if we go ahead and look at the example lead lag trader, let me go ahead and open this outside of MATLAB because MATLAB is currently busy. What you'll see is that we now have an HTML report that basically took the comments we had before. So if I move this over, what you can see is we start with a lead lag. So the first section becomes my header. It generates a table of content based upon each of the other sections. Then you can see my code, the results. So you can see, as we've shown before, the first test, the out-of-sample test, it did poorly. Here is the completed test, which just completed over here. We loaded the data into what's the surface fitting tool. So under apps, I'll show you that in a minute. And then we basically fit a surface to all the different results to try and get a feel for which one is the best performance. So if you look at it from a contour perspective, you can see that the best performance Sharpe ratio would probably be around here. So we fit a surface that we'll then use to approximate that. And then from there, we have the surface that represents the best Sharpe ratio. It's a decent fit, not the best. And then what we'll do is we'll run it through an optimization routine that's actually going to pull out the best fit parameter there, and we'll use that. So you can see that this actually shows the completed workflow of everything we've done in this. I basically wanted to give you a real quick example. Let me just run through the optimization piece. So we did the walk forward. Let's go ahead and run the optimization piece. So what it's going to do is it's going to search based upon the surface fit of that data. And what it came up with was 5 and 63. So if I go back and look at X, it says 5 and 63 are my best parameters. Close that. Go back to the plot. 5 and 63, this is the result that we would see for the entire data set. Often it trades. And it looks like it did pretty well using 5 and 63 for the entire day. So this is what we're going to use as our parameter, our lead lag trader. So what I want to do now is actually go back, kind of give you an introduction to how you can use events in MATLAB and how we can develop a system that works on events and is driven by such as quotes or trade announcements. So let me go ahead and clean up real quick here. So what I want to do now is actually go and open up the demo 1 example and walk you through basically kind of the concept of streaming data within MATLAB and how you can handle it. Many people are not familiar with how you can actually stream data and have MATLAB respond to incoming data. So this is kind of to set the stage for that, and then we'll talk about event-based data and basically events and listeners in MATLAB, which come from the object-oriented programming concept, but they're not very hard to incorporate once you kind of understand a little bit about MATLAB. So as before, what we're going to do is we're going to load in some sample data. So this is actually going to be taken from tickdata.com. It's a national best bid and offer sample data that they provide. It's located in the data folder. So you can see I have data. Running the add data will add this to the path. So what we're going to do is we're going to load that, take a quick look at it. And what you can see is that the data consists of a variety of different symbols, the bid price, the bid exchange, bid size, ask, and so forth and so on. And then we've added something called the type. This is basically how our market replay is going to understand what this is. So these are all bid and ask quotes. We tag them with quotes. Other thing is you could actually have trade executions that are reported as well, and that would be given a trade under the type here. So you can see the variety of, we have 1, 2, 3, 4, 5 different symbols all available in this. The next thing that I want to do is I want to create a simple display so I can look and stream the real-time quotes to the display. And the reason I'm doing this is to kind of give you a feel for how MATLAB can be used to do multiple tasks at the same time. And one of the ways is to do that is to use events and listeners, which we'll talk about later. But let me simply create a display. So the command here is just going to create a tabular display, and it's going to put the data in there. So this, if I run this, what you can see is I basically have a display for, I guess it's better over here. So I have a display that basically currently doesn't have a bid and ask price, but it also has all the ticker symbols. So it's empty currently. So we're going to just pull out those 3 fields. Well, actually, we're going to pull out the bid, ask, and price as well. Now what this next set of code here is actually going to do is we're creating a quote string which takes 2 inputs. So we're going to take the bid or the ask price, we're going to add an X to it, and then we're going to add on the volume. So that way we can have a textual display in that order, or in the table I just showed you. Quote string and quote string will do that. So if I go ahead and create this, so let me go ahead and minimize this. So if I go ahead and run this line of code, and then show you with the first value of the bid and the ask price, what you can see is it's going to give me a string answer like this. So it's going to actually take 130.07 and stick it in for the bid as an example. Now the other function we're going to create is an update display, which takes in the date time. So it's going to take in all these fields, the date time, then it's going to run quote string on the bid and the bid size, as well as the ask and the ask size, to put it into this type of format and stick it into this table. And that's what this is doing, is just sticking it in the table for, which happens to be number 4, is the IT UB one that we're working at currently. So I go ahead and run this, you can see that it actually put the timestamp and the bid and the ask quotes. So now I have a function that will update this table. So one way to do this within MATLAB that is often familiar for newer users who aren't familiar with event-based programming is to use a simple for loop or even a while loop. So what we can do is we can actually update this table and loop through all the data within the data set that we have. So within the table, so T is our data that we pulled in from the National Best Bid and Offer. We're going to iterate over that from 1 to 100, just to give you a feel for how this works. And we're just going to pause it so you can get a feel for how, so you can see it updating in real time. And then this draw now function here will force this display to update. Because if you don't use draw now with web graphics in MATLAB, MATLAB will run through all your calculations and then display everything later. This actually tells it to update the display in every iteration. So if we run this, what you're going to see is this display updating with a variety of different information. As we go through the quote history for the day, you can see the variety of different components being populated and changing in real time. Now notice that I can't do any other commands while it's currently running, because I'm currently locked within this for loop. So as long as this for loop is running, I can't do anything else with MATLAB. Now that's not very advantageous if I want to have an event-based trading strategy that reacts to different quotes as they come in. So I want to trigger different calculations as events. So the for loop is actually a poor choice to kind of create an automated system. It locks me within this event loop and I can't do other things. So we want to break away from being locked into anything and basically do what's called event-based programming. So one way to do that within MATLAB is to simply add timers. So you can actually trigger things through a timer. So what we're going to do is we're going to create another display. So this display is going to be updated but driven through a timer instead. And so we have a custom function that's going to do that. The type here is just going to display the algorithm to the command window. So if I go ahead and run this, we can go ahead and see what this function is. But basically what it is it has a set of calculations here that are going to keep track of the index. So every time I call this, it's going to add one. So this way it's going to control how I stream through data based upon where I'm currently at and how many times I've called the function. You can see I have the quote string and the update display as before. This finds which location in the table it is. And then the user table, which is defined as the input. And the data is basically going to update that data and do the draw now. So if I go ahead and run this function, or first what I'm going to do is I'm going to create a timer object in MATLAB. And what the timer is going to do is it's going to execute every quarter of a second, and then it has a callback or a function that it's going to run every time that the timer is invoked. So every quarter of a second it's going to run this function that's tagged as timer function. So it's that update display timer I just showed you. Now what it usually has is there's a source and event that actually come through. We're not going to use any of that data since all the data is encapsulated in this function, so we define them as empty. And then the user table, which is this object defined earlier, the data table, and then the symbol list are all passed in and kept constant throughout the iteration. So if I go ahead and run this, what you'll see is you're going to see this going to continue to iterate and run through this and update the table in real time. And you can see that it's going to continue to do that. Now the advantage is that I can actually declare new variables. And you can see I can use MATLAB while the table is being updated. So now I have an event-driven system that allows me to do multiple concurrent calculations within MATLAB. So I'm not locking the MATLAB calculation kernel into a loop of any type. I'm now open to do a variety of different things at the same time. You can see the variables and other things updating here as well. Now the other thing you can do is you can also run, so I just want to show that you can actually continue to run even within a for loop. So I'm running the for loop just to display the iteration while this thing continues to update. So now the MATLAB kernel is locked here. I can't do anything until it's done, but I can run two programs at the same time. So even though you might be running in a for loop, it's still MATLAB in the background is handling the different events. So this is not truly a multi-threaded programming environment, but it does allow you to kind of run concurrent calculations simultaneously. The thing is that different calculations are queued, so if you have a long-running calculation in one area, it's going to wait before it executes the other. So you do have to be cognizant of that. Now to shut this down, I just basically stop the timer, and then I'm going to delete the timer. So if I go ahead and do that, I have stopped the timer, and now the timer will no longer update or trigger. I've actually deleted it. So you might actually find out that, so I can also run timer find all, which will tell me if there's any timers available, and there currently are none. So sometimes if you forget, if you clear a variable, the timer may still be active. You should first delete it because that actually gets rid of it and gets it out of the MATLAB memory. But if not, you can just find timer find all to remove them. So that was one way to actually do an event-based programming with timers, and then you can create other programming constructs. But what I really want to do is introduce you to the concept of events and listeners, because the events and listeners allow you to define different programs that can react to an event. And so basically you have one component that's going to issue an event, and then you have different components, or algorithms in this case, that'll listen to the algorithm. So let me actually go back real quick to my slide real quick. So what we want to do is the streaming data is going to be issuing quotes continuously at a certain interval. We want two different trading strategies here to react to them based upon what their decision logic is and send a trading to the order execution system. So what we really want to do is have something, we want to have two traders that are listening to the data source and then running their trading strategies appropriately. So to kind of set the stage for that, let's talk about events and listeners. So let me go ahead and I think close everything down. So what we're going to do is we're going to create a simple streamer object, which is actually going to be driven by a timer. So let me go ahead, and I'm actually going to go ahead and open this up rather than run type. What you can see is I have basically an object defined in MATLAB. So you define an object as first a class, and an object is actually an instance of that class. So here's the class definition. It consists of properties, events, and methods or functions that know how to operate on the data or events that are contained within the object. So first we're going to look at the simple streamer, which is derived from class streaming, which is another one I'll show you in a minute, which is actually driven by a timer. And it has to implement certain functions. But the simple streamer, basically it has a price, which is initially 0, and it has 3 different events. It's going to say, I have new data, the price is going up or the price is going down. So every time that price is updated in this object, it's going to issue these events. And if there's anybody listening, they will be able to get some information and react to that. So the methods we have is the creation or construction function called simple streamer. Now because this is a subclass, we're going to actually pass in the period. So this is setting the period of the timer object, or how fast the streaming object will update data to its parent class. And this is how you invoke a parent class object creation. So basically we're going to pass it in, create a new object. It's going to inherit all the methods from streaming, which I'll show you in a moment, and then we can then use it. Now the function that must be implemented is the step function. So the streaming object has a timer that is then going to be attached to a run function. So all my subclasses have to have the step function for it to actually be called every time it's told to update by the timer. So the step function here is it's just going to generate a random price. It's going to display the price, and then it's going to notify everybody that there is a price who's listening to this event. And then it's also going to calculate whether the current price is greater than the last price or vice versa. And then it's going to notify people that it's going up or going down. And then, of course, it's going to save state with the price. So this is one way. Earlier before I showed you the persistence in the update and the NVBO display. This is one way to deal with persistence, is to use objects. You no longer have to declare global or persistent variables. You can then use objects to encapsulate data within them. So before I actually go to the next stage, let me go ahead and show you the streaming object so you can get a feel for what it's doing. Open streaming. So what we have here is streaming is derived from a MATLAB class called handle, which you must use in order to issue handles and events, or events and listeners. It has two properties that cannot be modified by anybody but itself, the period and then the timer object itself. The period was passed in before, as you can see. And then the creation function here is just a streaming function. This is how it's created. Could have a variety of different inputs. It checks if there isn't a period defined, it's going to define it as 2 seconds. Then it goes ahead and creates a timer object, stores the period information, and then you can see the timer function is then going to call a step on the object. So this is this object or any subclasses that are derived from it, such as our simple streamer. And then, of course, we're going to have a start function. So this is how I can start the streaming. So it's going to start the timer or stop it and stop the timer, as well as delete, or if I wanted to, while it's running, change the period. Here's a function that allows me to change the period. It'll start and then restart it as well. So from that you can see that there are start, stop, and different methods, and then this one's only implementing the step. So let's go to MATLAB, create some examples of these, and look at how these things work. So this first example, what we're going to do is we're going to create a simple streamer with a period of 1 rather than default. So if I go ahead and run this, let me go ahead and clear this. Let me go ahead and clear all for the moment. I think we'll be okay. So what we're going to do is we're going to run this code, create a simple streamer. And what you can see is I have a variable called simple streamer of class with a price of 0, the period is 1, and then it's contained a timer function. So if you notice, timer was not defined in there. I can also look at its properties. So these are the properties that are displayed. So I could also type properties to get a look at the properties that are available. But more importantly, let's take a look at the methods. Remember, I only implemented the step method. But I have everything from its superclass. So I have the creation method, set period, step, stop, start, and delete, which were all derived from the first one, as well as the methods from the handle, which also include add listener and notify. Now these two functions will become key later for notifying based upon an event, and then adding a listener based upon an event. So if we go back to the simple streamer object real quick, so one of the things you notice that I issued the notify. So this is derived from handle. So when the price is going up, I notify any objects that have subscribed to this through the add listener that the price is going up. So we're going to actually attach some different traders to this, kind of show you how this works. But first what we have is a simple streaming object that we don't even have to worry about issuing events. Let's just take a look at how that works. So I created a simple streamer object, right? So I have SS. So if I go start, what you're going to see is it's going to start issuing random prices, right? So it's actually a streaming data set now, and it's issuing the display. This is all it's told to do. I can also stop it. And now you can see I can stop it, and I can also delete it. Now I went through what streaming was before, And this is actually just going to do the same thing I showed. So if I run this, it's going to wait for 5 seconds, show about five random prices, and then stop. So it's done that. Now what I want to do is actually attach something to listen to these prices and do something based upon what those prices are. So we're going to actually create 3 different traders, and we're using anonymous functions, so these functions only exist in the workspace. But the function is actually going to display information, so it's just a display function that we're going to call trader1. What you usually pass in as the event source and the event data. We're not going to use any of that data in this example. We'll use some a little bit later, but I just want to show you how to attach a simple function that's just going to react to the event. So the first thing is we're going to create 3 different traders. Their goal is to do different things. So trader 1 is going to buy a random value of shares, and it's going to display that command window. Trader 2 wants to buy 100 or more, and we'll show you which event he's going to subscribe to in a second. And then trader 3 can sell all my shares. These are the 3 different trading strategies that we have. Now what we're going to do is we're going to assign each one to a different event. So trader 1 is only going to listen to have new data. So basically anytime a new quote comes through, he's going to buy a random set of shares. Trader 2 is going to listen only for when the price is going up. So when the price is going up, he's going to assume it's going to continue to go up. So he's going to say buy 100 more. He's going to keep doing that every time the price goes up. So our third trader is actually going to buy only when the price is, or actually he's going to react, sell all my shares when the price is going down. So very pessimistic trader. So when we run this code, the add listener actually attaches it to our streaming object. So they're basically subscribing to this event, and then it's going to call this function, trader1, every time that event occurs. So let me go ahead and run this. We'll start it, run it for 5 seconds, and then we'll stop and delete it. So what you can see is that trader 1 buys. Let me go ahead and open this up so we can get a better view. So you can see here what was just run. Basically when the price went up, trader 1 buy 3 shares. He's the random trader. The uptrend buyer bought 100 more. And then when price was 43.8, it was actually down. You can see trader 3 said sell all my shares. Trader 2 is not there. And of course trader 1 continues to buy because he's just buying on every announcement. You can see how that goes through the rest of the 5-second trading history that we have. So this is a very simple example of how you can create classes or objects that can react to events and how you can have different functions subscribe to the event. So what we did here, if I go back to this diagram, is we created a simple streaming object, right? So the streamer created a simple streaming object that then drove it. So everything's being driven by a timer interval. Here, he's issuing events. These guys are listening to the events. These were just functions. They listen to a certain event based upon how they were added using the add listener, and then were called each time that happened. So this is how you can do event-based programming in MATLAB. Now what you want to do is develop some more sophisticated ones, showing that lead lag strategy from before, as well as a market maker, and then also had another object that encapsulates a trading volume that's going to keep track of trading records. So this will give you an example of a more realistic trading system. So I'm going to go ahead and clean up everything and open demo 2. Now this is going to be the final demo that I'll really show in MATLAB before we'll talk about Simulink and Stateflow in a minute. But basically this goes through a similar concept, but what we're going to do is we're going to do this on the Microsoft strategy. So first, we'll load in the data. Now one of the things is that I've actually defined a data feed replay service. So all of my classes I've actually put under this agents folder. So I'm calling each of my classes, they're basically agents, either a trading agent, they're a data feed agent, or they're some kind of agent. You know, maybe they're an exchange agent. So the ones that are of interest is I have a Bayesian market making agent, a broker who's going to take all the orders and reply with a response. I have the replay service, the lead lag trader, and then I have quote data and trade data. I'll talk about a little bit. These are actually event data systems as well as the 2 I showed before. So the first thing is I have a data feed replay service. So let me just go ahead and open that real quick. And in the data feed replay service, it takes in the source as well as the period is optional. But it can take a variety of different inputs. It can take a file, it can take a table, or it can take a structure. And some work to do here is to actually allow it to connect to a database and pull data from a database. I'll leave that as an example for you guys to finish. But this is how you can extend it. And what this is going to do is it has a step function which notifies only with 2 different events that there's a trade notification or a quote notification. So one of the things is that it has some assumptions on the fields that should be in the data. And basically, if we go through and load Microsoft, let me go ahead and do this. What it's going to do is it's going to load the Microsoft data. The original data didn't have any timestamps, so we're just going to go ahead and add those for the day, starting with today's date. And then we're going to put it into a table object. So let me go ahead and take a look at what's in the data table object. So if I go ahead and open this up, the data is a data type container for mixed type data, very convenient and easy to use. You can see that it has named variables. You can also name the rows if you so desire. But what it has is symbol, so Microsoft, ask price, the bid price, the ask size, the bid size. These were randomly generated because they weren't included in this original data set, as well as the time, and then we added the quote, because these are all quotes. Now, if I had both trade and quote data to use concurrently, I'd have different trading data within here. So one of the things we're going to do is we're going to then, so we loaded the data. Now let's go ahead and create the default data feed replay service and get rid of some of the stuff we don't need. So if I go ahead and run this, what you see is going to take all that data, convert it to actually an internal representation that's going to allow it to stream it a little more efficiently, and basically it's going to be a MATLAB structure. So it's taking the table, converting it to a MATLAB structure, and then getting ready. So you can see that the feed, so the feed has these different properties. So it has a replay speed, which is the period, which is the period of the timer, which is also the period here. It's also reflected here in the period. So if you change the replay speed, this will be updated. It has an index, so this is the current index into the data of what it's going to stream out. It has a symbol list, so if I imported data that had more than one symbol list, it would actually update this. And actually, let me show you that that would be true, as well as the data in the timer object. And then this is here's an example of the data. So it's a structure with all these fields. And if I go the feed data of 1, you'll see the first one. I can also do and that's the last data point. So this is what's going to be streaming based upon the iteration or the timer. So every time the timer goes through, it's going to update the index with 1, and then it's going to stream out the next set of data. So let me actually show you an advantage of using it this way, because we can actually take this and we can actually create a different one directly from a CSV file. And the reason I do this is to show you that it can handle more than one instrument at a time. We're just going to run this back test on Microsoft data, but this is actually going to load the national best bid and ask data, tick history or quote data, national best bid and offer quote data provided by tick history or tickdata.com, and then we're going to show it. So you can see that it actually scanned through. It has those different symbols we showed before, and then you can see the length of it. So we could actually stream different data here. So if I do the data, the feed.data 1, you can see the current one. Let's just do the first 5 and see how many different ones we get. It's a 5. So let me do 1. You can see the first one, second one, third one. Now I have ITT, the fourth one, IEF, and so forth and so on. So you can actually stream multiple things. So if you also notice, I now have so I actually define it as the feed. So what we want to do is go back here and redefine the feed to run on Microsoft. Oops, let me just go ahead and clear. I unloaded the data, so we'll go ahead and load the data, create the feed. And now what we're going to do is we're going to create a monitor like we did. We're going to attach a GUI to actually watch the quotes update in real time so we can see our system working. And then we'll move on to the different components of the automated trading system that we were interested in. So what we have here is we're going to create the national display as before. This is where we're going to add a quote monitor listener. It's going to listen to the feed for a quote notification only, and then it's going to update the display with the current data. Now this is where we're passing in the event data. So before, passing in the event data, but we don't care what the event source was. We know that that's the feed, but you can also get the name of the source through this variable if you need that for your functions. We'll go ahead and start it, run it for 10 seconds, and then we're going to reset the index to 1 so that we can start the streaming simulation again later. So I go ahead and run this. What you can see is that it's going to have Microsoft, and then you're going to see that it's going to update the bid and the ask. So now what we're going to do is we're going to actually create a broker object. So what we're going to do is we're just going to take a quick look at the broker. It's going to contain two properties, a quote book. So it's going to keep a log of the current quotes for the current national best bid and offers, if you will. And then it's going to have a trade book, which must be observable to be updatable in the framework that we're using. So because I'm going to actually attach a property event listener to this, that's going to react when the trade book is updated. So that's where you need set observables so that a property change listener can actually listen to this. So the broker doesn't do anything but declare these empty properties. And then we have some functions. So there's an order table or a place order, which is actually going to go through and place the order based upon whether we specify the position as greater than 0 or less than 0. So these are market orders. It's going to assign an action and fill the order table. And it's going to return an order table back. So if you look at this function, you also get an order table for confirmation of what the filled order was. So you can see down here, we're going to actually define filled price as what it was based upon the bid and the ask spread, or based upon what the bid and the ask quotes were at that time, as well as the timestamp. The other thing is that there's also a function called quote update. So this is what our notification is going to be listening to, or this is what the listener is going to invoke every time there's a new quote from the data feed replay service. So this is going to basically go through and update the table with new quotes. You just saw that. This is actually going to be an internal quote book, so it's going to have the quote monitor that we showed in a GUI is actually a table within this object, so it's going to contain the similar table of price quotes as well. And that's all that it implements. So we'll go ahead and create this. We're going to actually go ahead and add the listener to listen to the quotes, run the quote update function. We're passing in the broker object and then the data. Go ahead and run this. And then what we can see is the quote streaming will be updating in real time. I'll go ahead and dock this. But also, if we look at the broker, we can see that I have a quote book. And then the quote book contains whatever the current quote is as well. So this allows you to have multiple quotes at once. We're just going to listen to one for this example demonstration. So now what I want to do is actually create some trader. So there's two different strategies we have. I talked about the lead lag trader before. So we're going to run the trading strategy that way. And then there's a Bayesian market maker, which I'm going to actually reserve discussion on what this one is doing when we move to the Simulink and Stateful example, because it's much easier to explain in the context of the diagrams that you'll see. The lead lag trader I'm going to open up just to discuss real quickly. So we look at the lead lag trader. Basically, it's got some different properties. So this is the leading and lagging parameters. It's going to keep track of its position, the profit. It's actually going to it's going to be assigned a broker, and it's going to contain it in this variable. Then it has its trader ID and then the symbol that this trading strategy is going to listen to. Here's some more historical data, so it's going to maintain a history of the data so that it can run over, because this data is coming in streaming. It's going to add the streaming data to the price history. And then as well, we have a signal that indicates when to buy or sell. The lead lag trader construction just go ahead and creates it, populates those fields, gives it a trader name, so you need a trader name, as well as the different parameters you want to use, as well as the symbol it's going to listen to. The strategy is actually what's going to be run every time we listen to new quote data. It's going to go through, it's going to parse it, it's going to make a determinant of whether it's a buy or a sell based upon what's coming out of the signal from the lead lag function we had before. And then it has an order, so it's going to place an order with the broker, basically pass the right information. So we're only going to pass in the lead lag trading object and how much it wants to buy. It's going to assign its ID to the broker, because that's what the broker needs to actually implement the order. And then we have add broker to add the broker so that it knows who to communicate the orders to. And then there's a plotting function that's going to update only every 1,000 iterations to just show you the status of this strategy. So if we go ahead and create that, what we're going to do is we're going to create the two. We'll talk about what this one does later, but it takes a similar one. So we pass in the parameters, the symbol it's going to subscribe to, so this is what it wants to trade against, and then give it a name. So we'll go ahead and create this. So we're going to create those objects. So now you can see I have the different traders, if you will. And then we need to add the broker, assign the broker to both of them, which is basically the same broker. So you can actually add more than one broker if you wanted to and handle them that way. Now what we're going to do is we're going to add the listener. So the listener is basically on the feed object, we're going to tell it that we want to subscribe to the market maker as well as the trader to listen to the quote notification and then invoke their own strategy based upon what the event data is. So we'll pass in the event data and they'll handle it appropriately. So we'll go ahead and run this one to define it. And then what you can do is you can see what what a listener object does. It has a source event, the callback, whether it's enable and recursive. So there's some properties here. So you can also use this listener handle to start and to unsubscribe or delete the listener too if you wanted to actually delete something after a time. So if the trader decided he's no longer in the market, you can stop listening to the data. So now that we have that, we're going to actually create another display like this one that's going to create and display the trade data. We're going to go ahead and dock this one too. What we're going to do is put this one down below, resize so we can see the quote on top, the timestamp and the information here. We're going to scroll over a little bit. So trades are actually going to be shown here. This is the quote. So this is actually the same information that their brokers contain. So any trade that gets triggered there is going to do it. These are actually listening themselves to the event. So this one is listening to the quote modification. We defined that earlier. When we created the table display, the trade monitor display, it's not currently listening to anything. So we're going to add a listener to the trade book. So this is where it's going to listen to the broker. Anytime that the property was set, basically the trade book property was set, so anytime a new trade order is entered, after the property has been set and updated, it's going to then trigger this event to just update it and display it here. So we actually have this trade record listening to the broker. So this is another way how you can have them trigger off parameters or property changes within different events. So we'll go ahead and define that one. Let's set the feed to about half a second just so you can see everything updating updating at a decent frequency. And then we'll go ahead and start it. So what you'll see is for a while you're not going to see any trading activity, but you'll see the quotes going through. You can see the market maker is starting to respond to the quote and the bid ask based upon its Bayesian market making strategy. After the iterations reach around, I think 65 or so, is that what the parameter was? At 63, you should start to see the lead lag trader actually making trades. So let's go ahead and see what the feed is at. Oh, you see it actually did update. So now we're past 70. So you can see that now there's the trader, the lead lag trader, and the market maker. They're all participating. If you notice, everything's updating at about half a second. The table, the GUI, I can continue to do other things within MATLAB. So now I have an event-based system that is just reacting and calculating only when the events occur. So let me go ahead and stop the feed. So what we could actually do is you can actually close these down, change the frequency. So you could actually delete the trade monitors and their event listeners, increase the frequency to about 1/10 of a second, and then run through this strategy more quickly so you can see everything updating. What I'm actually going to do is, in the interest of time, is go ahead and show you the published report here. This is actually on a different screen, but let me go ahead and show you. So this is the same code, goes through and creates things. What you can see is it goes through, populates it, runs it for a while, and then we actually shut it down. And then what we're going to do is we're going to run it to completion. So without having any plotting, update, or listening, you can see that keeping track of its profit, its position, where the trader was. So it's currently long 2, so it it's down 27.5. But I'll show you in a second how the strategy works. And then also the market maker, which goal was to maintain almost a 0 position, actually has about a profit of about 15 cents for the day after running through it. So let me just go ahead and show you what the calibration reports for the lead lag, which does the same thing later on. So event-based testing, we did the same thing with just the lead lag, ran through it, created it, and then we had the plot update, and you can see how it did. So it actually generated a final return of about 1.35% based upon the lead lag thing. We also kept track of the actual orders themselves in the table, pulled them all out. You can see the total cash that was generated from going long or short based upon 1 share or 1 to 2 shares. And then the final return. Similarly, we also have for the Bayesian market maker, you can go down and see its final result as well as how it was doing its profit and loss throughout the market, and then what the final quote was. So this is an example of creating an automated trading system within MATLAB with the different components. So what we're going to do is I'm just going to clean up everything here real quick, and then we're going to go back to the slides. Okay, now what we're going to do is we're going to actually talk about the production server. So how do you take one of those trading strategies that you may want to implement, or multiple trading strategies that you want to implement in an external system? So the way you can do that is basically through the MATLAB production server. So what the MATLAB production server does is it allows you to host multiple different MATLAB calculation engines, all running concurrently. The default configuration is 24 concurrent MATLAB executions, or 24 MATLAB workers as we call them. So you can run 24 simultaneous calculations. You can also get scaling by adding more workers or adding more capable hardware. So the process is that we basically run that algorithm that you want to run using a functional form interface, such as the lead lag function we defined earlier in the demonstration. You run that through the MATLAB compiler, and it generates basically a component technology file that you drop into the MATLAB production server. In this example, it shows a portfolio optimization algorithm, some kind of pricing algorithm, and then some risk analytics algorithm. So you have 3 different algorithms, all live, available for being run and called from a variety of different end systems. So the different types of end systems that are supported are Microsoft Excel. Add-ins directly can call from this. Python, Java, .NET, C, and C++ are currently supported. So from the front end, you use the client library for the appropriate environment, and then basically tell it how to send information or data back and forth to the production server. So an example is you can have a web-based trading system that goes through the web server, calling the production server on the back end. You can also directly use this as an automated system being called and invoked directly from a database. So if an order comes into your database, you can then trigger a trade or maybe some kind of risk analytics if you want, as well as can also be integrated within your web server. Then, of course, desktop applications, a variety of different forms can call directly into this. One that's directly supported out of the box without any code needed, we generate all the code for you, is Microsoft Office Excel add-ins. And then, of course, you can use a variety of other application servers to call into the system as well. So that allows you to actually take MATLAB algorithms and host them in a scalable way for multiple things to call maybe the same algorithm, or to manage a variety of different algorithms that are being called at different times throughout the day. So this is one way of taking MATLAB. You can take the production server and co-locate your algorithms close to the exchange where you might want to get better performance. So speaking of performance, this still runs at the speed of MATLAB, even though it's optimized for this still runs at the speed of MATLAB, so the linear algebra still performs the same. All the algorithms you develop still perform at the same speed. So what happens when you want to actually go beyond this and maybe enter the realm of high-frequency trading and develop algorithms that you can then compile to C or maybe put onto an embedded device such as an FPGA or an ASIC? So that's where we're going to basically talk about re-implementing the Bayesian market maker that I showed you earlier in Simulink and Stateflow. So I'm going to go ahead and transition back to MATLAB, open up Simulink and Stateflow, walk through this example, and then give you an illustration of how you can develop the strategy and use it to generate a variety of different code for different targets. Okay, so what we're going to do is we're going to actually show you the Simulink and Stateflow example, which I'm going to go ahead and open up here. So if I double-click on the example market maker, it's going to go ahead and open up Simulink, which is another platform product from the MathWorks. It's a block diagram editing environment for modeling dynamic systems. And what we're going to see is, let me go ahead and resize some of these things. So I'm going to show you a variety of different things, and then we'll run this in real time. But basically, so this is my model in Simulink constructed using a block diagram approach, where the inputs are signals, the blocks do algorithms on the signals, and then there's a variety of different outputs. So what it's going to do is it's going to import the Microsoft Ask from the MATLAB workspace, the bid, run it to my market maker, which is actually a stateflow or a stateful diagram that's going to tell it how to respond or transition from different states. And then the output is going to be the current estimate of the ask price, the bid price, what its position is, as well as a profit. And then we're going to run through an example profit and loss calculation, which here is basically taking the position, delaying it by 1 unit in step time, and then it's going to multiply that by the price, and yesterday's price, subtracted from yesterday's price, is going to give you the returns, multiplied by the position. That's going to give you the profit for the day, and then it's going to continue to sum those up to give you the cumulative profit and loss. So this will be a return series that we can look at. Now, if we look at the Bayesian market maker in Stateflow, so this is Stateflow. This is another product on top of Simulink. But what it does, allows you to diagram complex logic using states, or a stateful machine, if you will. So the initial state is defined here, and what it is, it's going to initialize a probability, set the position to 0, the profit to 0, and then it's going to call a bid-ask function. Now, if you look, I have these MATLAB function blocks surrounding that. So if we look at the initial probability is basically going to go through and it's going to create a using an initial seed, a distribution around x0 given a range of parameters. So this is going to be the total distribution that it's going to generate, and the distribution is a normal distribution, so we return that as variable p. So if I go back to stateflow, we have a similar one for the bid and the ask. So it's going to initialize the bid and the ask. What this is going to do is it goes through using the Bayesian estimation. So what it's going to do is it starts with that initial distribution, calculates the bid and the ask from that distribution, and then after every iteration it's going to update the distribution and try and narrow it in and estimate what the true price is from what the quotes are in the system. And this is going through the algorithm using a Bayesian methodology for that. I'll refer you to the paper to actually get into the details. There's a little too much to discuss in the remainder of this webinar. But basically, you initialize it, it goes to the quote. So it's going to be sitting here waiting for a quote. So when a quote comes in, what it's going to do is it has one of two choices. It can either go through, I'm going to sell. So the condition is if the ask is less than my estimate of the bid, I'm going to look to maybe do a sell order. And then it's going to update the probability based upon the current quotes. Or I could go through the buy order. So if the bid is greater than my estimate of the ask using the bid ask function, it's going to run through and change my position and then update the probability calculation. Now you can notice before it comes back to the waiting for the quote, what else it's going to do is it's going to go through another stage where after it goes through both of these branches, it then has to recalculate the bid and the ask to update the prices for what it's estimating, as well as it's going through an inventory control mechanism. So what we don't want to do is to buy too much. We want to try and stay market neutral within this. So this is basically logic that's going to prevent us from buying too much. And then the probability of the price in trade is within this MATLAB function. So if I double clicked on it, you can see it here. It walks through and updates the probabilities based upon the current values. So the reference for this was on the slide. I refer you to the thesis paper that talks about the actual math. This was lifted pretty much from that thesis. So if I go back to Simulink and stateflow, what I'm going to do now is I'm going to actually simulate this and show you in real time, and you'll see a similar performance to what we saw earlier. So let me go ahead and open up the scope. So if I go ahead and hit run, what you'll see is it's going to go through, load the data. It's actually compiling the stateflow on MATLAB logic for execution speed. And then you can see it actually run through the simulation. Given the gain, which is just the 1/2 the bid and the ask spread, the current values, what the market position is for the market maker, as well as the return series or the profit and loss. So you can see that it actually over time does generate a little bit of profit, even though it's meant to be market neutral. So this is an example of creating an algorithm within MATLAB and Simulink. Now there are a variety of tools for actually generating code out of this. You can generate code for a variety of different hardware devices through C or C++. This would be for HDL code generation or PLC code. So this is how you would go through and build the model. Another example, I'm just going to go ahead and close this, but if you notice within the space, when it ran and compiled the example market maker, it actually went ahead and compiled a MEX function in MATLAB. So this is a compiled version of the stateflow object. So that's an example of how you can compile this to deploy to other systems using Simulink and stateflow. So with that, I'd like to return to the slides and then conclude the rest of this presentation. All right, so we just saw an example of how you can generate and simulate the strategy within Simulink. Now what we're going to do is we're going to wrap up this seminar, or wrap up this webinar, by talking about a variety of different resources that are available to you. Now over the years, there are a variety of different trading algorithms or trading webinars that are out there that you can use to learn and get more information. The first one that kind of begins with the basics of what I showed with the lead lag and walks through the development and backtesting of a system is Algorithmic Trading with MATLAB for Financial Applications. Following in a similar vein, we're kind of learning to use MATLAB as well as develop trading strategies and backtest them. You can look at one that's specific to commodities trading with MATLAB, and then one that talks more about equities trading or basically trading based upon earnings announcements with MATLAB and FactSet data. And then of course there's a precursor to this one, which was called automated trading, which takes basically the concepts in the first algorithmic trading webinar, implements them as an automated trading system, and shows how you can integrate it with QuickFixJ as well as trading directly through XTrader from Trading Technologies. And then of course some more statistical advanced concepts such as co-integrations are talked about with the co-integrations pairs trading with econometrics toolbox, which talks about co-integration, the concept and how you use it, and then ends with the example of how do you develop a pairs trading strategy using co-integration. And then, of course, for those of you who may be interested in energy trading and risk management, there's a whole topic on that as well. So these are a variety of different resources that can help you get started and look at MATLAB in a variety of different venues. So if you need more information, want to find out more about these webinars, just want to hear more about the capabilities we have available to you, or want to talk specifically about some of the products I showed on an earlier slide, feel free to contact us. The contact information for North America is here. If you're attending today from outside of North America, please look up your contact information on the mathworks.com/connect. You'll find your local MathWorks office, or in some cases, maybe a MathWorks reseller. So with that, I'd like to end this presentation. So I'd like to thank you for attendance for today's webinar.